Hi there, I'm Mrs McTaggart, and this is the second lesson on integration, and we're looking at differential equations. Before doing this, you should have already done basic integration, okay? So a differential equation makes you think, oh, you're differentiating. You're not really. You're trying to get back to the expression or the equation you had before you differentiated. So it's like finding an expression for the original function, and it could be putting it back in terms of y equals or f of x equals, depending on what notation the question's using. So our method for doing these is you integrate as normal. So step 1 is you integrate. And don't forget your plus c. That's so important in these questions. Step 2 is you're always given some kind of equation to sub in for x and y. So we're going to sub in for x and y. And that gets us to find c. And then the last step is to rewrite your equation. And that will be in terms of y equals or f of x equals. Best way to illustrate this is, let's go on to some examples, okay? So here, they're worded so many different ways. So I'm doing about 4 examples, I think, and it just shows you all the different kind of wording of it. So in this one, it says f dash x equals 3x squared minus 5. Find f of x. So it's already telling you that it wants you to go from f dashed of x to f of x, which is clearly integration. And it tells you that f of 1 equals 3. Now, please remember this normally says f of x, all right? And f of x is just another way of saying what y is. So if you plugged in the number 1, you would come out with the answer of 3. So this will be your y value. So we replace x with number 1 and y with 3 in a little second. But step 1 was to integrate. So our opening line is going back to f of x, which is what it was before it differentiation. We're going to integrate, so 3x cubed all over 3. Increase your power, divide by the new power. Take away 5x, and don't forget your plus c. So if you don't have the plus c value here, you really have nothing to substitute into or find, and it makes it impossible to get the final 2 marks of this question. So now what we're going to do is we're going to replace x and y with the numbers we've said. So f of x is basically your y thing, so that becomes 3 equals. X gets replaced with a 1. Now I should have actually simplified there. That just goes down to x cubed. So I've got 1 cubed, take away 5 times 1 plus c. So I've got 3 equals 1 minus 5 plus c. 3 equals negative 4 plus c. And if you move the 4 over, you get 3 plus 4 is 7. So final answer is c equals 7. I don't know why I wrote it there. Let's write it underneath and just make more room. So c equals 7. And then the final step is to rewrite your equation. So you rewrite this line here in terms of f of x. Now you know what c is. So our final answer is f of x equals x cubed minus 5x plus 7. So you've essentially found out what we started with and then differentiated to get your opening line. And the 7 was your constant of integration. Remember we talked about we put this c in place of the value that disappeared in differentiation. So in this case, it was a 7 that disappeared. Let's look at another. So this one is now talking about gradient of a tangent. So don't freak out and start doing like all the stuff to do with tangents. It's basically saying that the gradient was this thing. Gradient is another way of saying dy by dx. We have to find the equation of a curve if it passes through 1, 4. So remember the equation of a curve normally always starts y equals. So it's wanting you to go back to y equals, which is going from the differentiated line back to what you started with. So we're going to go to y equals, we're going to increase the power. So it becomes 4x squared. Divide by the new power, so divide by 2. 3 becomes 3x when you integrate, and don't forget your plus c. Now your coordinate we're using this time is 1, 4. So y gets replaced with a 4. X gets replaced with a 1. I've just realised I haven't written that out first. Simplify that down, it's 2x squared minus 3x plus c. So we end up with 4 equals 2 times 1 squared. Take away 3 times 1 plus c. So 4 equals 2 take away 3 plus c. 4 equals minus 1 plus c. So that makes c equals 4 plus 1. So c equals 5. And all that's left to do is you go back and rewrite from this line here, y equals 2x squared minus 3x plus 5. And you know you can always check these back, differentiate it and check it goes back to your opening line, and you've done well as long as you've not messed up with the c value. So that's me done 2 examples. Here is another one. It looks very like that one. It's told you dy by dx is 4x minus 6x squared. You've got your coordinates. So this is going to be your x and your y. This is just worded differently. It says express y in terms of x. So again, it's asking you to go from dy by dx to y. So that's your clue to integrate. So this goes to 4x squared all over 2. Take away 6x cubed all over 3. Don't forget your plus c. And remember to tidy it up this time. So 4 divided by 2 is just 2x squared. 6 divided by 3 is 2x cubed plus c. Y is being replaced with 9. X is going to be replaced with minus 1. And we get this. Let me make some more room. So 9 equals negative 1 squared is just 1. So you've got 2. Negative 1 cubed, however, is negative 1. With a negative in front, so this turns to plus 1 plus c. So 9 equals 3 plus c. C equals 9 take away 3 is 6. So my final answer is y equals 2x squared minus 2x cubed plus 6. That is you done your differential equation. And then I've just got one more. I'm just going to a wee bit more work to this one to begin with. That should be a big old square root. So we need to prepare this one first. Again, this one says express f of x. So it's asking you to go from f dash to fx, so integration. But we need to rewrite this first as 2x over x to the half plus 1 over x to the half, which becomes 2x, 1 take away a half is a half, and then that just comes up and becomes a negative power. Right, now we can integrate. So f of x equals 2x, increase the power, becomes 3 over 2 divided by 3 over 2. This one, increase the power, add on 2 halves, just gives you 1 half all over 1 half with our plus c. Let's tidy this up. So flip your fraction, so that becomes 2 times 2 on the top, so that's 4. A 3 on the bottom. I'm going to rewrite this because I'm substituting in. This is why we have to rewrite everything in terms of square roots. So it's 3 halves, so a half is the square root, the 3 stays at the top. On this one, dividing by a half, flip it, is just times by 2. So we have 2 square root x plus c. Right, my coordinates, x is 9 and y becomes 40. So I have 40 equals 4 times the square root of 9 cubed all over 3 plus 2 times the square root of 9 plus c. Right, let's make some space. Okay, so this gives us 40 equals, let's work inside out. Square root of 9 is 3. 3 cubed is 27, divided by 3 is 9, times 4 is 36. Square root of 9 is 3 times 2 is 6. So 40 equals 42 plus c. Take away the 42, c equals negative 2. So f of x equals, and I'm going to keep it in this form here. I like that layout. So we've got 4 root x cubed all over 3 plus 2 root x, and then c was negative 2. So take away 2 on the end. Okay, I hope this has helped. Thanks very much for watching. Bye-bye.